Right, so for recording purposes, today is homeostasis part 2. Right. And here we have an octopus, and let's just see what's going on here. So today we're going to start our discussion with glucose. Remember, glucose is a type of sugar, right? And we need glucose, right? But we have to be real careful. Too much glucose is bad, and too little bit of glucose is bad. The amount of glucose in our bloodstream, right? Or it needs to be at a certain level. And I'm going to show you today how your body controls the amount of glucose in the bloodstream. Now, what's the number one reason for glucose in the body? Anybody wants to refresh my memory on your chat? Everyone should be able to get this correct. What's the purpose of glucose in the human body, right? Glucose. The number one reason for glucose is for respiration. In other words, how your body produces energy. Your body basically needs two things. It needs glucose and oxygen. And when you mix them together in your mitochondria, you get energy. Well, and we know the name of that process. I already said it. It's called respiration. Now, here's the thing. So we eat food, well, mainly carbohydrates, and from the carbohydrates, we get the glucose. Our digestive system will break down the carbohydrates using mechanical and chemical digestion to produce the glucose. Now, the glucose will eventually enter our bloodstream. Now, it's very important. Well, sorry, where does the glucose actually belong? Once your body absorbs it into the bloodstream, does it need to remain in the bloodstream, or does the glucose need to be delivered via the bloodstream to all the cells in the body? Where does the glucose actually belong? In the bloodstream, or does it eventually have to be delivered to the individual trillions of cells in the body? And the answer is obvious, right? It should be delivered to the cells, right? Let's draw a diagram here, right? A quick diagram, right? So remember, let's just draw a blood vessel. Let's say this is a capillary, okay? So that's a capillary there. And of course, next to these capillaries will be what? Cells, right? Remember, there are trillions and trillions of cells that will be very close to the capillaries. Inside the capillaries, I'm going to use these dots to be what? To represent glucose. Now, when you now eat and you digest the food, well, the glucose ends up in the bloodstream, like I mentioned. But remember, right? Inside the cells that have what? The mitochondria. Who actually needs the glucose? It's the mitochondria. So these, well, you all probably know what the mitochondria looks like. So these, the glucose has to, how you say, diffuse. That's a technical word there, right? It has to diffuse from the blood cells, sorry, from the capillaries and go into the cells where it will go into the mitochondria and it will create the energy. So the glucose it's actually a very good idea for the glucose not to remain in the capillaries for too long. Why? Then let me hear your reasons why, in case they ask that in the exam. What would happen if the glucose, or not enough glucose, leaves the capillaries? In other words, you leave the glucose to build up in the capillaries. So let me just say you have too much glucose in your capillaries or blood streams for too long. What will happen? I mean, obviously, your sugar levels will spike. That's obvious. If you have too much glucose in your bloodstream, and you take a test, your sugar levels will come back too high. That's a given. What I am asking is, why is having a high glucose level or a high sugar level bad? And that's the gist of my question, right? So some people are saying it's going to lead to diabetes, and yes, that is true. But the main reason is, right, the sugar will begin to, the glucose levels will begin to damage the blood vessel. That's the main reason, okay? So what's going to happen? Well, the vessel itself is going to get damaged. The walls of it is going to start to get, you can think of it like sandpaper. The yellow dots are like sandpaper, no? So as the glucose flows through, if you leave too much in it, it begins to damage the walls of the capillaries and your veins and your arteries. And of course, you all can imagine the amount of problems that's going to lead to. Nobody wants a damaged blood vessel in their body. That's going to eventually lead to death. Okay? And there are plenty names for it. It's just I don't want to get into all the technical names, but that's the how you say, the general idea. The glucose will damage your blood vessels, and it's very important that you get the glucose out of the blood vessels as quickly as possible. So you don't need to take down anything there as yet, right? So let's continue with the slides. So the octopus says, can you explain how the body controls glucose levels, right? By controlling glucose levels, it means it wants to get it out of the bloodstream as quickly as possible. Sure, can you reach in and pull out my liver? All right, so what's going to happen here? Your liver actually plays a very, very important role in controlling the amount of glucose in your bloodstream. Who would have thought the liver would have something to do with it? So the octopus is just going to reach in, grab his liver, and pull out his liver here, and that's the whale's liver there, right? So in case you don't know how the liver looks, that's how the liver looks. First of all, the liver has so many functions in the human body. I believe it has about 400 different functions. One of them has to do with glucose control. So let's move on here. Let's see what's going to happen here. You see that green bubble there that just appeared to the left-hand side of the screen? His name is glucose, right? So that green bubble is going to represent glucose. And he says, hi, I'm glucose. I am found in blood and in the cells and used in respiration. We already know that. So we have plenty glucose there. When your body has too much glucose, me and my friends are grouped together and stored in the liver and renamed glycogen, right? I'm going to explain all of that just now. Here's the gist of it. I'm going to draw back a blood vessel here. Let me draw it red for obvious purposes. So let's say this is a blood vessel. It could be a capillary, it could be an artery. It really, really, really doesn't matter. Let's say we have too much glucose in our bloodstream once again, just like before. So I'm going to draw plenty. This here is obviously dangerous. We need to get it rid. We need to get rid of that glucose. So what your body will do, if it have too much glucose, it will send it to the liver. So it will extract the glucose out of the bloodstream and send it to the liver. But you gotta get some technical names down. When the glucose is in your blood, it's called glucose. But when you send it to your liver, right, the glucose gets changed up a little bit, right? The chemical structure of it gets changed a little bit. And you no longer get to call it glucose. Instead, you call it what? Glycogen. So glycogen is just the stored version of glucose when it's in the liver. So if you look at glucose and you look at glycogen, they will look what? Slightly different, okay? Everybody with me so far? That when your body extracts the excess glucose out of your bloodstream, because it's dangerous, it gets it out of your bloodstream and it puts it in your liver and stores it in a slightly different chemical form called glycogen, right? So the first thing I want you to, well, let me complete this slide and then I'll tell you in what order to take down everything, right? Let me just get rid of the explanation here first, right? Now, the question is, how does your body know to do this? All right, so let's pretend, well, you have to pretend it's your body, right? So right now, let's say your parents for breakfast, instead of giving you like bread and egg and whatnot, they went and give you 10 donuts for breakfast. Does that sound like heaven, guys? That you wake up one morning and you see 10 donuts in front of you and your parents say, go nuts, right? So you, so you eat 10 donuts for breakfast. Obviously, it's full of sugar. So all that sugar ends up in your bloodstream. We call it a sugar rush, right? You have too much sugar in your body. How does your body know to say, hey, this is too dangerous in a way. Let me get that sugar out of the blood and let's put it in the liver. Well, it all boils down to something in two hormones that are made in your pancreas. Anybody remembers which part your pancreas is located? I did it when I did digestion. Where is your pancreas located? Your pancreas is located behind your stomach. Yeah, so somewhere right behind your stomach, right? And there's a hormone. I ain't giving the names of the hormone as yet. Yep, that will produce a hormone. Remember, hormones tell the body what to do. And it will create a hormone that will tell your body, hey, take that glucose and send it to the liver and store it as glycogen. But I didn't give you the full story, right? I gave you the story about having too much sugar in your blood. And we all agree too much sugar is bad. But do you all know anybody who suffers from low sugar? Does anybody know anyone who suffers from low sugar? But my mom suffers from, no, can't remember which one she suffers from. It's one of them, right? Right. So low sugar is actually bad also, right? Low sugar is when you don't have enough sugar in your blood. Remember, there must always be some sugar in your blood. It just cannot be too high or it cannot be too low. So let me look at this scenario here. I'm only going to draw a few dots over here to indicate that the person has low sugar in their body. In other words, they don't have enough glucose in their blood. You know what happens when you have low sugar? You start to feel weak and you just faint away or you just can't think and focus because you don't have enough glucose in your system, right? So what your body will do now, remember, in your liver, you have the glycogen. Does this make sense? Your body is going to detect that, wait now, you don't have enough sugar in your blood. Maybe we should take some of the glycogen and convert it back to glucose and send it in the blood. Does that plan make sense? That when your body detects that you have low sugar, the glycogen is converted back into glucose. See, your body has a plan. When it has too much glucose, it pulls it out and stores it in the liver. And when it has too little of it, the liver will give back the glucose. That's homeostasis. It's trying to maintain a balance of sugar in your bloodstream, right? Now, it's obviously going to be two different hormones. One hormone takes the glucose out of the blood, and a different hormone puts back the glucose in the blood. But the good news is both of them are made in the pancreas, right? So yes, someone said it right. The liver is a type of storage device. You know, it's a good way of putting it. How much people have a water? I'm going to assume everybody here has a water tank at home. What does a water tank do? When you have too much water, it stores the water in the water tank. And when water goes and you have too little bit of water in your water tank, any water tank to supply the water back to the house. So your liver is a storage device, but not for water, for glucose. Okay? So I just want to see what order to take down the notes over here. This is the order I want you to take down the notes. Take down this first and take down this second. You don't need to draw any diagrams here. Take it down in that order. Let me know when you are. All right, so let's go and have a look at the next slide and, see what adventures happen here. Right. Number 3, I want you to take this down. Does this note actually make sense? That glycogen belongs in the liver and glucose belongs outside. Because when you take the glucose from outside, it stores it as glycogen. And of course, when you have low blood sugar, it takes it back out and reconverts it to glucose. So keep that, but take down the note, but it's very important to know that glucose belongs in the blood and glycogen belongs in the liver. Okay, so take down note number 3. All right, so here we have a little animation. So that's the pancreas, right? That's found behind your stomach. Hi, this supposed to be hi, my English is so terrible. You all know, this supposed to be I with a little apostrophe here, right? Hi, I'm the pancreas, and I do a lot of things, including making 2 hormones. So the name of the 2 hormones created by the pancreas is one called insulin. You want me more? I'm sure you know about already. And the other one is glucagon. You see, that's the next G word. It has 3 G words: glucagon, glucose, and glycogen. What does insulin do? Insulin converts glucose to glycogen. Remember, glucose is found in your bloodstream and glycogen is found in the liver. So tell me something. Will process number 1 happen if you have high blood sugar or low blood sugar? In other words, I'm asking, when will your body release insulin? When will your pancreas produce insulin? When you have high blood sugar or low blood sugar? Reason it out in your head. Right, it will do it when it has what? High blood sugar. Because you want to get the sugar out of your blood into your liver. And if you have low blood sugar, then your pancreas creates glucagon, which will convert what? The glycogen back into glucose and release it into the bloodstream. So it can raise your low blood sugar to a normal level. Right? I want you to take down this note. And yes, I want you to put in my little extra the little high blood sugar and low blood sugar part. Okay? And you can draw a diagram of our pancreas if you wish, right? Right? Let me know when you're finished, right? So I know people are going to mix up glucagon, right? Right? Glucagon and glycogen, right? Right? And you're going to mix it up. So the only way I just thought of is, doesn't your pancreas look like a gun? Look, if you put a trigger here, you'll see that it looks like a gun. Gun. All right. So that should help you remember that glucagon, right, is made in the pancreas. Right. Sorry guys, I know it's lame, but I hope it helps. Right. Right. Obviously, I made a slight grammatical error here. Sorry about that. Right. I do a lot of things, including making two hormones. All right. So let's move on. Right, so let's do an actual animation here. Let's see if you all could predict what's going to happen. So remember, these green things represent glucose, and the big red is the bloodstream, and then you have what? The liver. So the whale, if you look at the whale there, the whale says, hey, it seems I have high blood sugar. And if you look at the diagram, it does look like you have high blood sugar. Look at the blood and look at how much green blobs it has. The green blobs, once again, represents the glucose. Which one will your pancreas make? Insulin or glucagon? Predict it for me. The whale has high blood sugar. Too much glucose in its blood. It needs to get rid of that and store it in the liver. Come on, guys, let me know which one will the pancreas produce, insulin or glucagon? And you all are correct. It's supposed to be insulin, right? So the pancreas will make insulin and it will send it to the body, right? And of course, what your body will do, once it receives the insulin, it will say, all right, well, let me show you instead of telling you, right? Look at what's going to happen. The insulin, keep your eye on the insulin capsule, right? Glucose in blood is high. Pancreas is notified, right? So that's the order of everything. Eh? The glucose, sorry, in the blood is high. The pancreas is notified of the situation. And then it sends, you saw that, right? It sends the insulin to what? To the liver, right? Or to the bloodstream. It sends it out to the body. I'm gonna just replay that. You all see something there? You all notice what happened? Look at what happens. A lot of the glucose is going to disappear from the blood and go where? Into the liver. When, by the way, without looking back, once the glucose is stored in the liver, what do we call the stored version of glucose? Don't look back in the notes. See if you can remember. What's the G word I'm looking for? What's the G word I'm looking for? When the glucose is pulled out of the bloodstream because of the insulin and stored in the liver. Right. It's stored as glycogen. Right? So because most of the glucose has been pulled out of the blood, the glucose in the blood is now normal, right? And we get what inside there? Glycogen. No, I'm not going to ask you to draw this out. I just wanted you all just to see it animated. Obviously, I can't ask you to draw an animation, right? I just needed to follow and pay attention to it, right? Now, based on the answers I'm seeing and the people responding, I'm guessing you all understand it. So let's look at the opposite situation now, right? look at what happens now. It's daytime and how you say, the whale isn't feeling too good. And the reason he isn't feeling too good is because his blood sugar is too low. Look at his blood. His blood only has a little bit of glucose. It doesn't have enough glucose. So he's feeling weak and whatnot. So what happens now? Well, step one, the glucose in the blood is now too low. The pancreas is notified. Obviously, which one the pancreas is going to produce now? It's not going to produce insulin. It's going to produce glucagon. So it sends the glucagon, look at it, it went across to the body. And what will the glucagon do now? It will change the glycogen back into glucose. But glucose doesn't belong in the liver. So once it's changed to glucose, it shoots it out back into the blood. So look what happens. The glycogen disappears from the liver and it goes back into the blood as glucose. Glucose blood is now normal. Right? So I hope you all enjoy the animation. I hope it makes it stick in your head, right? It's always good to see things in animated form, right? Whenever I get a chance, I try my best to animate it for you guys. Let's move on, right? So let's have another situation here now. Well, that's all I know. Hey, you mind stuffing back my liver in me? Remember, for the explanation, the octopus had taken out his liver, so it's only fair he puts back its liver after the explanation is finished. But the octopus is late for his CSEC exam, so he busses out. Poor whale, right? Left without a liver. All right, so you all get a little mind relaxer here. You all know how to play this game from last week. Choose any number between 1 and 50. 1 and 50 is included. Choose any letter of the alphabet and choose one icon, one token. And let's hope none of your items end up in cauldron. I'll play with you guys, right? I already can't remember. I'll choose 26K and I will choose the potion. Let me know your choices on the chat. 26K and the potion for me. Let's see the unlucky items. So I'm 26K and the potion, right? The first cauldron has the unlucky number is 5. Anybody out of the game? If you chose 5, you're out. Right? I didn't see anybody choose 5, so I guess then everyone's still in. The unlucky letters are R, Y, and U, right? Which spells Ryu, Street Fighter. All right. And the unlucky token is the hat. So I made it true, right? None of my items appeared. Let me know who won and who lost. All right. Zaria, you lost. Right? And Jordan, you won. Nevita, you won. Malachi, you won. Daniel, you won. Neola, yes now, huh? You won, I believe. Yes, Zaria, look like you're the only one who lost. All right, let's move on. So that's it for homeostasis, right? We discussed the 3 types of homeostasis, the main types that are found on the CXC syllabus: glucose, water, and temperature. Let's talk about excretion. Now, a lot of people actually don't know what excretion is. Excretion is how your body gets rid of toxic materials in your body. Remember, your body is a huge biological machine. All machines produce waste products, okay? All machines. At the end of the day, you are a machine. So you will produce toxic or waste substances in your body. and your body must have a mechanism to get rid of it. You can't let toxic things build up in your body. You will die. Okay? So let's have a look at excretion. Everyone take down the new topic, excretion. Turn to a brand new page. Don't even if your last page only had one line written on it, turn that page and write excretion on a brand new page. All right. Oh, what is this strange monster saying? We have a lot of drawings to do today. Oh, I guess you all know that already. So let's begin with this. Yes, you're going to have to take down everything. Let me explain first. There's no rush to take down. I will give you a chance. So in the exam, if the examiner asks you to, define excretion, this is exactly what you want to write for it. Excretion is the process by which metabolic waste, you have to use this term, metabolic waste. Metabolic, remember your body is remember I told you it's a machine, right? And inside your body has a whole set of chemical reactions. Right now, you have billions and billions of chemical reactions happening in your body every second of your life, right? Metabolic waste is waste that happens from chemical reactions. So don't let the word metabolic get to you. Just make sure and use it in the exam, right? So excretion is the process by which metabolic waste, which is bad, are eliminated from an organism, where you are the organism, obviously. Now, what are the parts of the body that are involved in excretion? Not every part of your body is involved in excretion. These are the main parts of the body: the kidneys, urethra, urinary bladder, but better known as your bladder, skin, liver, and lungs. All of these things deal with excretion, or in other words, getting rid of all those nasty, toxic substances from your body. I know the most obvious question is, so what's the difference between these three things? Because all of them start with U, and number 2 and 3 almost spell the same. And don't worry, I have a nice little diagram for you all to draw that will show you the differences between those parts. You don't have to worry. So in the exam now, if they ask you, hey, can you list some of the toxic substances that can be found in your body? Well, urea, carbon dioxide. Yes, water is actually, you might be surprised, right? You must be saying, water? How water could be toxic in my body? Let me explain. We all associate water as good, right? Your body needs plenty water, but it's how the water is used. If somebody says water is good, and then I throw you in the ocean and you could drown, because in that water is not being used properly. So you're going to realize that water sometimes can be a bad thing in the body. And the bad water, there must be a way to get rid of it. Okay, so I just mentioning that. And salts, right? Like, yeah, we all need a little bit of salt in our body. But when I say salts there, I mean excess salts. Suppose one day number in the last example, you wake up one morning and your parents give you 10 donuts and you went crazy. Suppose tomorrow, Sunday, Carnival Sunday, you wake up and when your parents give you a plate of food, they give you a mountain of salt prunes for breakfast. How would that be? Won't that be a case that you have too much salt in your body? I guarantee you, if you eat a plate of salt prunes, you're going to have to rush you to the hospital. Too much salt in your body is a bad thing, okay? So take down every single thing on the screen here, every single thing. Let me know when you are finished. All right. Now, I'm not going to ask you all to draw this one now, right? This has to be done for homework. take a screenshot in the exam itself, right? Oh, but by the way, I just wanted to just to show you something here, just related. Remember, the renal artery, being the one with the toxins, comes into the body here, and the clean blood, once the bladder, not the bladder, once the kidney filters it out, it comes out clean. But you have to understand that the renal artery goes into the kidney, and the artery leaves the kidney. So at the end of the day, the red and the blue are embedded inside. Well, part of it in any case is embedded inside the kidney. I don't know if that was obvious, right? But you will see that in this diagram here, right? I know it's not complete and it may confuse some people just now. This is an incomplete diagram because the renal artery, what? Supposed to be continuing upwards like this. I know last year caused some problems, right? I'm not too sure why, right? And of course, this will lead back out. So it's very, very popular in the exam that they will give you a blank diagram of the kidney and they will ask you to label it for them. Now you'll see that it have plenty different layers here in the kidney. The whole thing basically is called your capsule, right? Now that's like the outer layer, the whole encasing, that's the capsule. The cortex is right under the capsule. The medulla is underneath the cortex and it has these kind of fiber like lines here. You just can't mistake it for anything else. The medulla has that. And then this, how you say, the cortex is kind of like the outer part, but then it kind of makes this little curved piece here, right? The curved piece here, this piece here, is called the renal column, right? And by the way, when all the toxins are extracted, the toxin goes where? Through the ureter to the bladder. Right, so here's my advice. Take a screenshot, and when you get a chance, draw this as neat as possible in your books, right? I'm not going to ask you to do this in class. This will take you a good half an hour to draw properly. Okay. Right, take a 10 seconds and screenshot this. Right? Right, so I just want to address one more, guys. All right. So the year is 4000 AD, and you are stranded on a strange planet. Oh, so this is a little game here. I probably forgot I made this game. Right. So apparently, let's just follow the instructions over here. Okay. Think of a country on your planet, well, Earth, you would like to visit. So anybody has a country that they would like to visit that they haven't visited as yet? A country, not a city, a country. Let me see if I could say I always wanted to visit Transylvania, right? But I can't spell Transylvania. All right. So that's I always wanted to visit Transylvania. Right? America is not a country. America is a continent. So you probably meant United States of America, right? Right. So let's follow the instructions. Everyone write down the name of the country they want to visit. Write down the name of the country. So for me, it was Transylvania, right? When you write down the name of the country, let me know what is the third letter of the country. So for me, it was Transylvania. So my third letter was E, right? What is the third letter in your country? If any of your letters appear, if the letter appears, you lose, right? So let's see what the first plant says. P K, and oh, I lost, right? So if any of your letters appeared, you lose. So I lost because my third letter was E. Let me know if you won or one person won, two people won. Nev, Sophia, you won. Neola. Uh, oh. All right, let's move on. I had forgotten I made this game, to be honest with you. All right, you're going to draw this one. Don't worry, you're not drawing the complicated diagram. You're not drawing this, okay? But before you start to draw, right? Remember I told you all that your kidney is responsible for what? For filtering out the toxic substances. Now, if you zoom into your kidney is made up of thousands and thousands of small, small filtering devices inside your kidney, right? And this is how it actually looks, right? Something is blocking my view here. These tiny, tiny things are called a nephron. Now, when you zoom into it, it looks like this kind of yellow stick here, okay? Like I said, you have thousands and thousands and thousands of it. So what happens? Your renal artery, right, will split up into tiny, tiny, tiny capillaries. And what will happen? The capillaries will rest inside of these things called the nephron. Now, the nephron has this curved cup-like shape. That curved cup-like part of the nephron is called the Bowman's capsule. What this device will do, it will take the toxins out of the renal artery. And then what comes out of it is clean blood. But remember, the clean blood goes where? Into the renal vein. Bad blood comes in from the renal artery. The nephron, which is inside of the kidney, will filter out the bad substances, and the good blood will leave the kidney through the renal vein. Take a wild guess, right? Where does this lead to? Anybody wants to take a guess? The good blood comes into the renal artery, and the clean blood leads through the renal vein. So that means all the toxins will be inside here, and it will be removed from the kidney. So anybody wants to take a guess of where this yellow tube is leading to? Where do you think it's leading to? All the toxic substances, right? It's headed to the ureter, which is connected to what? The bladder. Does that make sense? All the toxic substances remain inside here, and the toxic substances go to the bladder, but before it reaches the bladder, it has to go through the ureter. Yeah. Now, this here is a very simplified diagram, right? So I need you to draw this for me, right? Right. Draw this for me, label it, and then I'm going to explain with an animation how this whole device operates. It's pretty cool. Right. So we have a little animation here, right? So let's say the place is really hot, okay? So I'm going to test you a little bit from last week. If the place is really hot, does your brain produce plenty ADH? In other words, a low amount of ADH, or will the amount of ADH be high in your body? Which one will it be? The place real hot, sun burning you. ADH is going to be low or ADH is going to be high? Right, a lot of people are getting this wrong. Remember, ADH loves water. ADH tells your body to hold on to water. Okay? So if the place is hot, the ADH has to be high. Your body will produce plenty ADH. Why? If the place is hot, your body doesn't want to lose water. It wants to hold on to water, right? Great. For those who got it wrong, you think that jogged their memory a little bit? When the place is hot, the amount of ADH produced will be high, right? So that's yeah, I know I'm gonna keep like trying to refresh your memory every opportunity that I get, right? So here's what's gonna happen. Your body has some stuff to get rid of. It has water, but when I say it has water to get rid of, I'm talking about excess water. It has salts to get rid of, urea to get rid of, and glucose to get rid of. Sometimes it does have too much glucose and whatnot. But anyway, the point is, all of these things are found in your blood. And I kind of color code it, right? Blue is water, yellow is salts, purple is urea, and white is glucose. So what's going to happen? All of these things come in from the renal artery and it goes into the Bowman's capsule. So look at the imagination, imagination, the animation here, right? Sorry, I think I said yeah, it's green. Sorry, I probably said yellow. All right, right, but it's green, right? But I have the color code here, right? The salts is green. Sorry about that, right? So what's going to happen? All of those things are going to end up, look at it, right? It's going to disappear because it's flowing and it will end up in the Bowman's capsule. Here's the thing. The Bowman's capsule is like a little filter. The blood continues to flow, right? The red part continues to flow. This is how the blood is flowing, by the way. The blood is flowing, right? It's containing all of these particles, right? Excuse me, I have to draw a few arrows, right? But you see the substances like the water, the salts, the urea, and the glucose. It's going to get filtered through the filter in the Bowman's capsule. So look at the animation now. All of those circles are going to disappear and end up in the yellow part, better known as filtering, and it ends up over there. Everybody with me so far? All the potential bad things end up in the yellow part. And remember, this yellow part goes to where? The bladder. It's eventually headed to the bladder so we can get rid of it. However, the place is hot, right? Now look at this. The place is hot. Look how much water look how much blue circles end up in the yellow part. The place is hot. Do you think your body should what? Get rid of all of that water? Should we send all of that water to the bladder? Yes or no? I mean, it's good that we got rid of the well, a little bit of glucose is end up in your bladder, right? You're not supposed to have too much, right? A little bit. It's good that we getting rid of some of the glucose. It's good that we getting rid of the salts. It's good that we getting rid of the urea. But remember, the place is hot. Why am I throwing away all that water to my bladder? I should keep that water in my body. So this is where your ADH comes in. Your body, your brain says, whoa, 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 we can't get rid of that water. You mad? So it produces ADH, plenty. And what will happen? The ADH will tell your kidney, hey, that water that go into your bladder, save it. Pull it back into your body. So look at the animation here. Keep your eyes on the blue circles. The blue circles, right? You notice what happened? Two things get pulled back into the body. Most of the water and some of the glucose, right? I really don't care about the glucose right now. I more care about what? The water. The truth is, glucose is not supposed to end up in your bladder. I mean, a little bit always ends up, right? But glucose is supposed to stay inside of your body. If you ever take a urine test and too much glucose end up in your urine, you have a problem and you need to take care of that. So you all notice something here, right? But the more important thing I want to focus on is on the ADH. Remember what I told you about ADH. ADH tells your body to hold on to the water. Don't waste. You see the process of pulling back things into your body. Remember, pull it back into your body. Yeah? It's called reabsorption, which makes sense, right? Reabsorption. Quick question. If your body pulls in too much water, do you, I'm just saying if the body make a mistake, right, and pull too much water in, do you think it will try to push back some of the water the other way? Well, what are your thoughts on that? Let me just say your body made a mistake. It released the ADH. The ADH pulls the water out of the yellow, but let's say it pulled too much water out. Do you think it will push back in some of the water? The answer is yes, right? Your body is really good at maintaining it. Like, and then your body makes mistakes, right? But it's always ready to correct its mistakes. So you'll see a diagram with that just now. What would happen if the body pulls out too much? It will have the opportunity to push it back in to the yellow part. Okay? And all the remaining stuff here, the little bit of water, the salts, and the urea, they go to the bladder to be excreted. Let's have a look at the opposite scenario. Let's say it's nighttime where the place is real cold. Remember, when the place is real cold, do you need to hold on to water? No, right? So let's redo the process. All the waste substances coming through what? The renal artery. They will eventually go into the Bowman's capsule. The Bowman's capsule will filter out all the potential stuff that needs to be removed from the body. Quick question. Will your body be producing low ADH at this point in time or high ADH? The place cold, right? It's going to produce low ADH because your body don't need to hold on to the water. The body's like, hey, get rid of that water. We don't need plenty water. The place cold, right? So your body only makes a little bit of ADH. And because it makes a little bit of ADH, it only pulls back in a little bit of water. It reabsorbs a little bit of water. So look at the animation now. You notice it only pulls in what? A little bit of water back into the renal vein. Most of the water stays in what? The yellow part to go to the bladder. So that is why on a cold day or a rainy day, you go to the washroom more because there's more water going to your bladder. And you notice once again, in the reabsorption process, it pulls back in as much glucose as possible. Once again, in a healthy person, glucose is not supposed to really be in your bladder. It really supposed to stay within your body. Right? And once again, if the body makes a mistake and takes too much water out, it will have the opportunity to send it back in to correct its mistake. Right? Right. Right. So, and remember, my explanation is just for if it's either a hot day or a cold day, right? I'm not going to go into whether it's a hot and cold day at the same time, right? Let's keep it simple, right? It's either the day hot and you want to keep water in your body, or the place rainy and cold and you want to get rid of the extra water, right? All right, so everybody with me so far? You don't have to take this down. I just wanted you to see it in what? Animation form, so it sticks into your head. Right? Everyone okay so far? Before we move on? Right, good. All right, we're coming close to the end of class. Actually, guys, this is the end. That's the last thing I did have to show. Let us see. I don't want to play this game right now. Let me just. Right. This is what I want you all to take a screenshot of as the last thing in class, right? This year, I want you to draw it in your books when you have time, right? Well, by the way, remember, you all know what filtration is. Filtration is when you filter out the stuff. Remember, I told you all that if the body pulls out too much of something and it wants to put in or correct its mistake, the opposite of reabsorption is secretion. So secretion is the body's attempt, well, in this particular diagram, to correct its mistakes. Because I guarantee you, even though your reabsorption supposed to remove certain substances, it doesn't always do a perfect job. Sometimes it might take too much out. So then it needs to put it back in, right? So do me a favor, screenshot this. And of course, I want you to draw it back into your books when you get a chance, right? So what we have next week we just should be the last week on excretion. And I want to do some past paper questions on this particular topic, right? And, we'll be completely finished with that topic and we'll start something new. All right, guys. So as I said, right, I know one person wanted me to say back what the homework was for the past few months. And I'm also asking all the integrated science people to stay back. Everyone else is free to leave.